Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, June 2nd, I think, yeah. So the problem is detonate the maximum bombs. So basically we have a list of bombs, and the range of a bomb is basically defined as the area where the effect of that bomb can be felt. So for example, you have this bomb, it's in the range, it's a specific range where its effect can be felt, which is just like a normal bomb, right? And the area is the shape, and the area they mean here is basically the shape of a circle with the center as the location of the bomb. So for example, this is the center, and this is the circle around that center, okay? And then the list of bombs is represented as just a list like this, with the coordinates being x, y, r, where x and y are the center. So here 2, 1 is the center for this one, right? X is 2 and y is 1. And then the radius is r. So for example, this one, the radius is 3. So you see here we have 3. Okay, so that's the idea. And now you can choose to detonate only a single bomb. So we don't detonate multiple, only a single one. But that bomb, once it's detonated, it will detonate all the bombs that are in its range. So this is important. Now, we need to clarify what is the range here. What do they mean by in the range? But, and then the bombs that this one detonates will also detonate the ones that are in their range. So you can think of it as cascading effect, where, let's say bomb 1 detonates, and then it has in its range bomb 2, then that bomb 2 will detonate. If it has in its range another bomb 3, that one will also detonate, right? So that's the idea here. And given this list of bombs, we want to return how many bombs, what's the maximum number of bombs that can be detonated if we are allowed to detonate only one bomb. So we detonate only one, but we have the choice among the list of bombs we have which one to choose, right? And we want to know among all of the bombs we have, which one, if we detonate it, will get the max value, and we want the max number of cascading bombs detonated. And we want just the number, this number, the maximum number. We don't want the bomb itself, just the maximum number, okay? Now let's go back to this range thing here, lies in its range. So what do they mean by that? Well, what they mean by that is basically the center of the second bomb needs to be in the radius of that bomb. Okay, what do I mean by that? Let's take an example. So this purple bomb here, right? If it detonates, it will detonate the green bomb. Why? Because this is how much is the radius for the purple bomb? It's 4. So it's 1, 2, 3, 4, and the center of the green bomb is here. So you can see the center is right in the radius of the purple bomb. It's right at the end. Okay, if it was here, it will get detonated. If it was here, it will get detonated. But if it was, let's say here, if the center was here, the green bomb won't be detonated because it's not in the radius, right? And so the purple bomb will detonate the green bomb. But if we look at the green bomb here, right, what's the radius? The radius is just 3. And so 1, 2, 3. So it stops here. So before the center of this purple bomb, which means that if we detonate the green bomb, we won't be able to, that won't detonate the purple bomb, right? Because it's not in its range. The definition of being in its range is that the center of the circle falls in the radius of that detonated circle. Okay, I hope that makes sense. And so if we look at this example, what's the answer? Well, we can just detonate the purple bomb, and that will cause the green bomb to detonate as a result, and so we have 2. Okay, so let's take a look at this third example, which is slightly more complex. So with this example, the red one is actually the best one, because so the red one, which is marked with 0 here, basically that's just the indices that we of the list here. So 0 has the radius of 3, and here 1 is basically 2 cells here, and so this is 3. So you can see the circle with 1, which is denoted here as its center is here, falls in the range. And so it will detonate 1, but it will also detonate 2, because you can see this falls in the range. If you take the distance between the two centers, 0 and 2, you will find that it's it's smaller than the radius, which means it's within the range. Okay, so once it detonates these, then because 1 was detonated, then as a consequence, 1 has just radius of 1. And so it just here, just covers here. So for 1, we don't have any additional detonated cells, but for 2, which has radius of 2, so it's 1 and 2, 1 and 2 will detonate this circle 3 because it's in the range. And so since we detonate circle 3, which has the radius of 3, so that means 1, 2, 3, that means it will detonate this circle 4, right? And so now how many we have? Well, we actually detonated all of them, which is 5 circles. Okay, so the first thing we said is that it cascades, especially in the third example we saw. Like if this circle detonates another circle, and then that circle detonates another one, let's say, well, this is actually doesn't detonate it because, so let's say this one, which says center is here. Let's say we have another purple one here, right? That gets detonated, okay? And so you can see here, then this purple one, if we had another circle, let's say orange circle here, where its center is here, then this one will be detonated because its center is in this one. But if we detonate the orange one first, the purple one won't be detonated because its center is not in the range, okay? And so the property that we want to sort of handle here is the cascading effect, right? The first thought you might have, right, is that, okay, I have circles and one can detonate another one. Let's just do 2 loops, right? Let's just do 2 loops. And then for each circle, count how many it will detonate in just one loop, in another loop for j. But the problem with that is, in this case, for example, for the blue one, you will count only the purple one. You won't count the yellow one here, or the orange one. You won't count it because you will stop at the purple one, right? And that's the main insight here. And so that tells you need something more recursive, because you will keep going as long as there are more bombs that get detonated. And so that's where we can think about, okay, so we need recursion, maybe, but how do we handle this? The other insight is that the problem says that only if the center is in the range of the circle. Okay, so for example, in this case, you can see the purple circle is in the range of the blue one, but the blue one is not in the range of the purple one. And so the relationship is sort of, can be one direction, right? So for example, the blue circle has one direction, detonates the purple one, but the purple one does not detonate the blue one. And so you can see if sort of here, we want recursion, we want basically to keep going as long as there are more bombs that gets detonated, and we have a direction. So immediately you should think about, okay, let's represent this with a graph, right? Where the nodes would be the circles, and the edges just are, if a circle fits in the range of another circle, then there is a node, then there is an edge from the container circle to the contained circle, right? So for example, here we would have a node from the blue circle to the representation of the purple one, and then we'll need another node from the purple one to the circle orange one, because there is because the orange one is in the purple one. But we don't have a node like this because the purple one is not in the orange circle, okay? I hope that was clear. And so now with this graph, with this representation of the graph, let's number our circles here. Let's say this is 0, this is 1, this is 2. Then now with this, it should be easy to find which circle we should detonate, because if you just look at the path here, this one, the path is 2. If we go from 0, the path is 2. If we go from 1, we can just go to 2. So the path is just 1. If we go from 2, the path is 0 because we can't go anywhere. So which one is best? Well, it's best to pick this one, to start from this one, and the max is 2. And so if we do that and use DFS, we can just take the maximum nodes we can reach. Okay, and by reach here means just using this representation, just traverse it all the way until you can't go anywhere, right? And so now that's pretty much the idea here. Just do DFS, represent it first. You create your graph using this idea here of there is an edge if the circle is inside the source circle. If not, then there is no edge, right? Now the main question becomes, now that we established that we can just use DFS, the main question becomes, okay, how do we check if the purple circle is in the blue circle? I know visually we said that the center needs to be in the range, but how do we calculate that? Okay, so let's see how do we do that. Well, for this center to be in the range, all that needs to happen is for the distance between the two centers to be smaller than the radius, right? That's all it needs to be. If it's smaller, the distance between the two is smaller than the radius, then that means it's inside the circle. And so that's exactly what we want to do. So how do we calculate the distance between these 2 points? Well, we can actually just use the Euclidean distance to do that. And so how do we calculate that? So let's say for the blue one, let's say it's x1, y1, the center. For the second one, the purple one, it's x2, y2. Then in that case, the distance is going to be just the square root of the difference between the two coordinates, the two x coordinates, plus the difference between the two y coordinates. And this is going to be the distance. Okay? This is just the rule for the Euclidean distance for the distance between any 2 points. Okay? And so this one we can simplify it by distance squared is just equal to x1 minus x2 squared plus y1 minus y2 squared. Okay? And what did we say we want? Well, we want this distance to be just smaller than the radius. This is the radius for circle 1 for the blue one. Okay? So how do we, now that we said we did square, then we just need to square r1 as well, so r1 squared. Okay? So let's do the solution we just saw in this overview. So first, we need to create our graph. So a graph, again, is just nodes. For each node, we'll have the neighbors, right, in a list. So that's just going to be basically node to list of nodes. So this is going to be basically I, which is the index of the bomb, to the list of bombs in its range. So I is the key, right? And then the values are going to be just the list of bombs in range of bomb I. Okay? And so we need to go through each bomb and just check. So let's call this bomb 1, and we'll enumerate bombs. And then we'll check every other bomb. Let's call it J and bomb 2. First, we want to make sure that it's not the same bomb, because if it's the same bomb, it shouldn't have an edge to itself. And then we want to check if it's in range. So, and let's check in range. Well, basically we check if bomb 2 is in range of bomb 1. So, checks if bomb 2 is in range of bomb 1. If that's the case, then we want to say that there is a node, because if this is the case, that basically means there is a node from bomb 1 to bomb 2, right? Because there is an edge from bomb 1 to bomb 2, because bomb 2 is in the range. So the destination needs to be in the range of the source. So that's what we'll do, but we'll just add the indices, not the bombs themselves. And it's directed, so we shouldn't do graph J append I, because it's directed. So now we need to implement this function that we discussed, which checks if one bomb is in the range of another one. Okay, so let's just put this again, just to make sure we remember it. And so what do we need to do? First we need to get the coordinates, right? Because those are what we need of BAM1. And then we need similar thing for BAM2. But remember, for BAM2, we only needed the coordinates. We didn't need the radius, right? Because we only check that the distance between this coordinate and this coordinates is smaller or equal to this radius, right? And so we just return exactly that. So what's the distance? So let's first calculate the distance. Well, we said it's just going to be minus x2 squared, right, plus y1 minus y2 squared. And we said instead of taking the square root, we'll just check that this is smaller or equal to r1 squared, right? That way we don't need to do the square root. So, and now we should have our graph at this point. Now we just need to do our DFS, right? And so to do our DFS, let's just define a function called DFS at I. And now we want to go through every node. So let's just go through all the BAMs. And for each one of them, we want to do DFS at that one. But we also want to keep track for each one of them how many nodes it can reach, so that we can get the maximum nodes we can reach. So that's what we'll do here. Best is equal to the max of the best and the number of nodes this DFS can reach. And then at the end, we want to return BFS, the best we have. Okay. However, for our DFS here, we want to create a visited set so that for each node, we don't visit another node, neighboring node multiple times, right? Now you may say, okay, why not do this here and do it for all of them? Well, because this is, remember, we don't know which circle if we start from we get the best answer. So if we do the visited set here, we may skip a circle because it was part of the range of another circle, right? And so that's why we initialize a visited set each time, so we can start from scratch for each circle and calculate the number of nodes it can reach independently, okay? And so that's what we do here. And now we just need to go through the neighbors of this BAM I. So we just look at the graph that we already constructed here. And now we want to do DFS of J. But we also, for each one, remember what we want to count is how many nodes it can reach. And so we want to increment with how many nodes J can reach. But here we shouldn't initialize with 0 because we want to count this node I, okay? And so we initialize with 1 to be able to count it. And then for each one, for this J, we are not adding 1 plus here because why not do this? Well, because we will end up adding that J on the next call to DFS of J with this count. And so since that is what will be returned, we don't need to add it here. And so at the end, we want to return this count, okay? There is just one other step, which is visited. So we want to say that we visited this I, so we don't visit it again. But also here, we don't want to visit something that we visited already, because otherwise we'll calculate the same bomb that was detonated before. We'll calculate that it's detonated again and double count it. So we want to prevent that with this here. Yeah, I think that's pretty much it. We need to define this n, which is just the number of bombs. So let's just call length of bombs. And that should be it, really. Yeah, that should be it. It's just BFS, so let's run it. Just DFS, sorry. And looks like it passes. Let's submit. And that passes as well, okay? So again, yeah, the two insights here. The first one is definitely to understand this in range. What do they mean by that? Which is basically just that the center is in the range of the other circle, which basically means that the distance between the two center is smaller than the radius, right? Or equal, right? And then the other idea, once you got that one, is to understand that it's a directed graph, and from there it's easy to figure out that you need to do DFS. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.